Good morning. It is my honor to share my ideas with you. I'm Wei Guo, and today we are going to talk about the safety monitoring technology applied in semiconductor overhead hoist transfer. This is my members. Our members have Wen Guangwei, Weiting, and our advisor is Shenghe Wang. If you have any problems, you can email to me. And next, this is our content. The first, we are going to talk about our motivations, talk about why we want to establish these systems. And next, we will have the purpose. So, after this, we will talk about our experiment process. Finally, we will conclude our solutions. So, the first, we are going to talk about our motivations. As you can see this figure, as new automation technology improve, automatic material handling system plays an important role in modern factory. And in semiconductor manufacturing, they use OHT as a transporting device. Our project is according to this device to have the development. So, what is overhead hoist transfer? This is a device that can transport the materials to another position. So, there are three features of OHT. It can save cost and manpower. And the second, it has a rapid transportation, so it can shorten the production cycle, and it has fully automatic control. And this is a box that can carry the wafer, and the OHT system can carry the box and have the transportations. As you can see in the figure, this is a wafer box, and also called FOOP. But there are some security issues behind this transporting process. As you can see in our animations, there's an operator coming to and it will operate our systems. And he started up the device. This is a normal process, but sometimes it get crashed. So what if the machine gets crashed? It will reduce the lifetime of the machine, and the dropping occurs over the wafer. So the wafer will drop it outside the FOOP. And the manufacturing efficiency will be decreased, so it will get result in the cost increasing. And there are several sensors and on the systems. So I will introduce these two systems. So the first one is Smart FOOP, which is developed by Innocence. So this is a sensor that can detect that if there is an impact outside, but this sensor have problems. So the module size is too big to install, and it doesn't support any real-time measurements, so it has a delay problem. And the next is a WaferSense, which developed by Cyber Optics. It has problems too. It needs to constantly modify my material control systems. And the last is torque sensor. This torque sensor's problem is the volume is too large to install inside the FOOP, and it is very expensive. So next, we are going to talk about our purpose. So, above our aforementioned problems, and we propose a no-sensor structure. So we hope our device have a self-monitoring and a smart torque monitoring and without any sensor. So we design a developed safety structure referred to an existing OHT device. So we propose a device which can integrate the smart function device, a smart mating for with automated judgments, and the device defeat the impact. It will stop and we can rescue the people from dangerous. And we use the more torque mechanism which inside the motors, and we hope our device don't have any sensors, and our device can save the cost. So integrate this for these things. So we develop this system, our OHT simulation platform. And next, we are going to talk about our experiment procedure. So we use the solutions, and we take 4 parts. So the first one is the PC calculations, artificial intelligence estimating, and the torque estimating, and the force judgments. So integrate for these 4 parts, we develop the systems. So next, we are going to talk about our experiment research procedures. So we found laser stroke problems, and we established the system structures, and we create a mathematical model. So in order to design a safety systems, and we will have the interference test. So if the threshold got reached, so we are going to get into the manual mode. So in our system structure, we have a controller to control our drivers, and the drivers will drive the motor and the reducers to pull up our fault box. And this is our mathematical models. So we combine this parts of the systems. So the first one, we are going to have the driver to drive the motors and the gear ratios. So the gear will start up, and we want to calculate the disturbance. So we brief our mathematical models here. So in comparison to the real system and the equivalent models, so we hope the real system can be equal to the equivalent models in order to calculate the solutions here. So in this figure, in the origin like this is a velocity command. So we will send the command to outside, and then the command, and this the blue line is an observer which dictates the real-time input detections. And next, we will have a safety designs. So we use the servo motors torque mechanism inside these motors to dictate that if there is a collisions or the impacts from the outside. And next, we will have an interference test. So in the interference test, I was simulating the stroke problems. So if our device detects that it's stroke, it will have a torque disturbance, as you can see in this figure. So next, if the threshold got reached, we set threshold safety values. So if our device detects that it's over values, it will go into the manual mode. So before the disturbance, it starts as the procedure is normally proceeding, and after the disturbance, we'll go into the manual mode. So in the manual mode, we can pull up the device or push our device down. So if our device detects that there's a collisions or simultaneously there's a under personnel under the box, and we can pull it up and rescue the people, and after that we can push it down back to the initial positions. And this is an important figures, shows that the convert the auto mode into the manual modes only takes about 200 milliseconds. So it is faster than the sensor we aforementioned. So it has no delays problems. So this is our whole experiment research procedure. And finally, we are going to talk about our conclusion. In our conclusions, in our device, we can use a smart technology to prevent the machine from damage from stroke. And a safety self-monitoring technology without torque or flow sensor is proposed based on the mathematical model of the OHT. The torque information of the driver motors in the OHT can be estimating the lifting force. So our device can estimate the lifting force to prevent the damage from stroke. And we look forward to promote the system applied in robotic arms and the mechanism. This is our whole simulation process. I will show you by video. This is our simulation process, and now we will start up our device. And this is a normal process of the OHT, but sometimes the doors will open accidentally. And sometimes there was a person pressed through under the box, and suddenly it got struck. So now we can close our doors and pull out our device and remove a person and pull it down. This is our whole simulation process. Thank you. This is our whole simulation process. Thank you for watching my videos. And this is the reference. This is the end of my speech. Thank you for attention, and thank you for listening.